AWS Identity and Access Management. If you're working in AWS, you're probably working as part of a team. It might be a small-sized team, a medium-sized team, or even a large enterprise-wide team. Regardless, there's going to be more than one person that needs to access the AWS account that you are working with and deploying your IT implementations into. Well, giving each of those different people their own username and login and permissions to access the system is an important part of good security, and that's what Identity and Access Management, or IAM, is all about. In this nugget, we'll take a high-level look at IAM. We'll talk about the different pieces of it, which includes users, groups, and roles. And then finally, we'll talk about the glue that ties it all together, IAM policies, the permissions that each of these users, groups, and roles can have. If you've been following along with this nugget series in order, you may have noticed that, at least to date, I've been signing in with the exact same account that I set up when I registered my AWS account at aws.amazon.com. This user that I signed in with automatically has access to everything inside of AWS. I have full administrative access to the system. I can do anything. I can look up anything. There is no restriction on what that user can do within the confines of my account. It's also called the root user. And if you're familiar with Linux administration or Unix administration, or if you're a Windows administrator, you know the administrator user, these are users that you typically don't log in with. You should not be using the root user to do your day-to-day activities. Yes, there are cases where you need to temporarily access things as your root or administrator user, but really, root user should not be used. Instead, what you should do is you should have a collection of users that can do the things in the system that they need to do and that only have the permissions or the privilege to accomplish exactly that. We call this the principle of least privilege. And the idea being that every user who accesses the system only has the privileges that they need in order to accomplish their job or do what they need to do. Identity and Access Management, IAM, is the tools that Amazon provides built right into the console that allow you to manage all this. So effectively what we can do is create and set up users, or identities as they're known in Amazon, and then we can assign permissions to those users. We can create groups and roles and assign permissions to those groups and roles. And of course users can then be assigned or applied to groups and roles in order to get those permissions. We're going to talk about all of these things and how it's organized right now. We'll start by taking a look at how IAM is organized. And it can seem a little bit confusing at first just because of how many different moving parts there are, but we're going to talk through one by one and I think it'll make a lot of sense by the time we're done. So initially we've got users and then groups, roles, and finally policies. To begin with, IAM users, maybe the easiest ones to understand. IAM users are simply identities. They are what we are going to use to log into the system. You and I and anyone on our team who needs to access our AWS account. An IAM user and an identity is made up of the following pieces of information: a login name and a password, obviously, a group membership if they happen to be a member of a group, and they probably should, any direct policies that apply specifically to that users, and something called an access key pair. We'll talk in a second about what an access key pair is. Now, IAM users get their own unique sign-in URL. So to date, we've been signing in at aws.amazon.com. Well, that's no longer going to be the case. When we set up IAM, we're actually going to get a sign-in URL for our account itself, and that's where we can use our username and password. This URL is unique to our AWS account, and that's great because that means that our usernames don't have to be unique across the entire AWS spectrum. If all of the AWS customers were using the same sign-in URL, well, all of their IDs would have to be unique, and that would mean that all of my users would have to have a unique ID across all of AWS customers. Because I have my own unique sign-in URL, my user's identity, their login name, only has to be unique within my account itself. We can also set up, of course, password policies for our users. So we'll see inside of our demo nugget how you can choose different password policies like mixture of upper and lowercase characters, the inclusion of numbers, the inclusion of special characters. We can enable or set up self-service password reset. That's a really good idea, a really good thing to do, so that users who forget their password can go to a website and say, oh, I forgot my password, and the whole system will walk them through getting a new password or a new link emailed to change their password. And then lastly, this is also really important, kind of a new security feature these days, but really, really critical, multi-factor authentication. Multi-factor authentication, or MFA, allows us to set up a token so that users not only sign in with their username and password, but then they have to punch in a number from a token that maybe they have in their pocket that's constantly regenerating, constantly changing. They are also beta testing right now, setting up multi-factor authentication with SMS texting so that users can actually get a code texted to their phone, and then they have to key in that piece of information along with their username and password. So finally, the access key pair. Let's talk about exactly how that works with users. Users are going to use their login name and password when they use this unique sign-in URL here. But if users are not going to sign in with the URL, let's say that you're going to have a software running in the background that is going to access AWS, well, that piece of software needs an identity. It needs a user associated with it. And instead of using the username and password, that piece of software is going to use the key pair. So using the RESTful API or using the command line interface to access AWS, instead of using username and password, uses these key pairs, one of the key pairs. And any user can have up to 2 active key pairs at a time. You can always deactivate, delete, or create new key pairs anytime you want, and that allows it to very easily refresh a key. So if you've got a piece of software out there, it's probably a good idea to refresh and change and update those key pairs every now and then, just on the off chance that those key pairs are hacked or they're lost or they end up in the wrong person's hands. Well, you can create a new key pair, update your software with the new pair, and then disable the old pair, and that software will never lose its access. It'll have consistent access the entire time. From there, I think it's easy to understand the concept of groups. An IAM group, like the name implies, is just a collection or a group of users. And the reason you put users inside of a group as well, one, so that you can give them a group name. You can identify all of those users together. Maybe they're all in the same department. They're all part of the same team. But secondly, and more importantly, you can assign that entire group the same set of policies. Policies, as we'll learn momentarily, are the permissions. That's what says, oh, well, you can access AWS EC2 instances, or you can access S3 storage. So by giving a group the policies instead of individual users, you can more easily manage access when you just simply add a user to a group and they inherit the policies that that group has, or you remove a user from the group and they lose the policies, or they lose the permissions that that group has. A couple of other points about groups. Users gain membership permanently. Now this is to differentiate them from roles, which are temporary. So yeah, of course users can always be removed from a group, but once you've put a user into a group, the policies that apply to that group now apply to that user, and they will always apply to that user whenever that user is accessing the system until you remove them. So it's permanently in the sense that you have to physically remove them from that group. And of course, like I've been saying all along, users inherit policies via membership. So you put a user into the group, they inherit those policies. When you remove a user from the group, they lose those policies. Now, similar to groups is the idea of IAM roles. And an IAM role, we've drawn it here with a little bit of hat, is kind of a temporary group. So similar to groups, they have both a name and a set of policies, and members of the role, people who have this IAM role, are going to inherit those policies. But groups or roles also have a set of trusted entities. And the reason they need trusted entities is because users can assume a role, but only temporarily. So if you're a user who is trusted by a role, that means that you can assume that role. You can, well, put on this hat that we're using here to illustrate it, right? So temporarily a user puts on the hat, they become that IAM role so that they can perform the actions that are associated with the policies that that role has. In order for this to happen, that user has to be listed inside of that role's trusted entities. The role has to trust that user before it will let them put on the hat. And this is very important. Some AWS resources can also put on a role or can also wear that hat. The great use case here that Amazon likes to describe is an EC2 instance that needs to access some S3 storage. Instead of giving an individual user access to S3 storage and having those user credentials stored inside of an application that's running on that EC2 instance, you can actually have the EC2 instance assume the role of S3 administrator, and the application can tell the EC2 instance to go perform those activities. So you get a buffer, a layer of security there, so that you don't have to distribute credentials inside of your application code, which can have all sorts of problems associated with it. So roles are simply temporary permissions that a user or a resource can put on, can wear, like a hat. And the one important thing to understand about roles is that these policies are not cumulative. So when a user puts on a role, when they assume a role, they actually lose their old permissions. They are temporarily becoming someone else and getting different access to the system in order to get those permissions. Now finally, as I described it, the glue that holds all of this together, IAM policies. And policies, like you probably have figured out at this point, are the permissions. They're the permissions that a user can have assigned to them, a group can have assigned to them, or a role can have assigned to them. So policies are actually set up and maintained individually or separately from any of these different things, users, groups, and roles, and then a policy is assigned to one of these entities or one of these things. An IAM policy is fairly straightforward. It simply has a name and a description. It's got permissions and the resources those permissions apply to. And the permissions and the resources are described inside of the policy in something called a JSON document, JSON. So policies use this JSON document style to write or define their policies, and because JSON can be a little bit confusing and their JSON is very specific for AWS, the best way to write a policy is actually to use the policy generator that AWS provides. We'll show off this in the demonstration nugget on the AWS IAM. It's also important to get familiar with something called the ARN format when you're working with policies. So policies identify resources with this Amazon resource name, ARN as it's called. And the ARN is unique across all of AWS. It's the way to identify any given thing inside of AWS with this completely unique name or this completely unique string. Again, you'll see some examples of that when we go over this inside of our demonstration nugget. And then finally, there's 3 different types of policies that you need to understand. To begin with, there are managed policies. These are policies that AWS provides for us. There's something like an S3 administrator. That's a common set of policies that many users of AWS are probably going to need. So AWS provides, they've already written that policy, they've already written the document, it's out there inside of your policies if you go look for them inside of your dashboard. And you can assign that policy, to any of those managed policies, to any of the users, groups, or roles that you create. And that's differentiated from custom policies. Custom policies are policies that you create. So you may need a unique mixture of administrative access to one resource, read-only access to another resource, as well as viewing access on a third resource. You can create those custom policies yourself and store them inside of your own policy list or your own policy library, you might think of it as. And then finally, inline policies. Inline policies are just custom policies, but they're actually built and associated with an individual resource, a group, a role, or a user. So a few moments ago I just said that IAM policies are described or maintained independently of any of those things. Well, that's not true for inline policies. An inline policy, let's say you build it on a group, you assign the policy to that group, or it's built with the group and it's always assigned to that group. If you delete the group, the policy goes away, right? So a regular managed or custom policy, if you delete the group that it is assigned to, that policy remains in your policy library, your policy repository, and you can always assign it to a new group, user, or role. But if you create an inline policy on one of these things, that policy is tied to that resource, and when that resource gets removed or deleted, the policy will get deleted as well. So inline policies, there might be some use cases for them, but you probably want to focus on managed and custom policies when you're working with IAM. So that concludes this nugget on AWS Identity and Access Management. Just to recap, IAM is all about users, who can log into the system and what they can do once they're logged into the system. We use users, groups, and roles to identify who's in the system, and then we define permissions for each of those things with IAM policies. I hope this has been informative for you, and I'd like to thank you for viewing.